stellar mass, supermassive, AGNs, quasars, and blazars. The many ways to describe a black hole. Hi everyone, this is Howard from the Hollow Science and Nature Center. Welcome to another Star Talk Tuesday. On a planet with just over 8 billion people, each with their own innate qualities and learned perspectives, it can be daunting to anyone trying to understand the many different labels created by and for a single planetary species to describe itself. In a similar fashion, that same planetary species in the pursuit of astronomical understanding creates multiple labels for a single type of astronomical phenomenon, depending on its innate qualities and, necessarily, perspective. Luckily for us, understanding astronomy and astrophysics is a lot easier than trying to understand the other 8 billion of us. The astronomical and astrophysical phenomenon in question is known as a black hole, a place in space where gravity is so strong that once entered, the escape velocity required to leave exceeds the speed of light, making it impossible for anything that must obey the law of physics to get out. In the simplest sense, black holes form in the collapse of a massive star at the final moments of its existence. The implosion of a star 25 times the sun's mass will create a black hole around 5 times the mass of the sun. Most of the star's original mass was blown outward in an explosion called a supernova. This occurred immediately after the crushing gravitational implosion that took the mass equivalent to 5 of our suns and squeezed it to a point of maximum density, becoming what is known as the stellar mass black hole. There are an estimated 100 million black holes scattered throughout the arms of the Milky Way galaxy. When astronomers look into the hearts of galaxies, they find black holes that are so massive they dwarf stellar mass varieties by many millions of solar masses. In other words, not 3 to 15 times the mass of the Sun, but millions and even billions of times the mass of the Sun. So massive, they are called supermassive black holes. Dormant in our local volume of intergalactic space and time, supermassive black holes typically sit undisturbed and do nothing other than warp space and time with no apparent consequence to the rest of the galaxy. Occasionally, clouds of intergalactic gas and dust, sometimes planets and even stars, are inexorably pulled into the gravitational field of a supermassive black hole. Once they get close enough, the extreme tidal forces will have completely disassembled any complex structures into individual atoms and nuclei, swirling into an accretion disk, generating enormous X-rays before falling forever into the black hole's event horizon, or the point of no return. The energy seen coming from disks around these supermassive black holes as they feed on infalling matter earns them the label of active galactic nucleus, or AGN. These AGNs are the brightest persistent sources of light in the universe. The galaxies that host these AGNs are called Seyfert galaxies. They account for 10% of all galaxies and some of the most studied by astronomers. Seyfert galaxies are home to AGNs that create bright active cores that do not blind us to the rest of the host galaxy. Galaxies that host AGNs that are so luminous that they blind us to the host galaxy and are visible across billions of light years of space are called quasars. These quasars, or superluminous AGNs, have been known about since the 1950s. More than 1 million quasars have been found. The nearest to us is about 600 million light years away. Quasars have so much infalling matter that the accretion disk gives off unimaginable amounts of energy, thousands of times greater than that of the entire Milky Way. These most luminous objects are used to measure the greatest distances in the universe. In some cases, polar jets form from infalling matter perpendicular to the rotating accretion disk found around black holes. These relativistic jets are beams of ionized matter kicked out of the accretion disk of the AGN at percentages of the speed of light. These beams, fired from a gravitational cannon, can be several thousand, several hundred thousand, or even millions of light years long. Out of the million galaxies that we can see hosting quasars, many of them have powerful relativistic jets. And of those, statistically, we will see some of them appear to have their beams pointing at us. Because their beams are pointed near or directly at us, they will be seen even brighter than quasars. These are called blazars. Once a confusing object, we now know that they are just feeding supermassive black holes that just happen to be pointing one of their bipolar jets straight at us. Today, we know of a few hundred blazars. The closest is 2.5 billion light years away. Stellar mass, supermassive, AGN, quasars, and blazars. These are the different ways to describe a black hole based on its innate qualities and our perspective of it. Thanks for joining us, folks. We'll see you next week with another Star Talk Tuesday.